With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our question is, a body stretches a spring by a particular length at the Earth's surface at equator. At what height above the South Pole will it stretch the same spring by the same length? Assume that the Earth is spherical. Okay, so what we have to assume that our Earth is spherical. So let us suppose this is our Earth. Okay, now this is the North Pole, this is the South Pole, and this is our equator. Okay, now what we have been given that a body stretches a spring by a particular length at the Earth's surface. Okay, so let us suppose at this point at the equator, the body stretches a spring by x. Okay, so let us suppose that at South Pole acceleration due to gravity is equals to g meter per second square. Okay, now we have to tell at what height from the South Pole, okay, at what height from the South Pole does this extension in the spring or the stretch in the spring will be equal. Okay, so the value of g at the South Pole we have assumed at g, so at a height of h the value of g will be given as g into 1 minus 2h upon r. Correct. Now the question is based on the concept of the variation of the value of acceleration due to gravity due to the rotation of the Earth. Okay, now as we know that at equator the acceleration due to gravity is given as g minus omega square r. Correct. Now what will happen over here is when the body is at equator, it will experience a gravitational force in the downward direction. Correct, mg dash, and the spring will apply a spring force kx. So at equator what will happen is the extension kx will be equals to mg dash. Correct. Now let us suppose this is equation number 1. Now at a height of h from the South Pole, what will happen is, again when the body is hanged from it, it will experience a downward force, correct, or the gravitational force, and it will be mgh, correct, and the spring will apply a spring force. So at the height of h from the South Pole at equilibrium, what we will say is kx is equals to mgh. Now let us suppose this is equation number 2. Now the extension should be same, so what we can say that equation number 1 kx and kx should remain the same, correct. So what we will get is mg dash will be equals to mgh, correct, on comparing equation 1 and 2. Okay, now the mass of the bodies will remain the same, correct, so m will get cancelled out. So what we get is g dash will be equals to gh. Now g dash is what? G dash we have calculated as g minus omega square r, correct. So it will be g minus omega square r will be equals to gh is how much? G into 1 minus 2h upon r, correct. So from here what we get is g minus omega square r will be equals to g minus 2gh r, correct. Or what we can say is our height will be equals to omega square r square upon 2g, correct. Now here omega is the angular velocity of the Earth, no, correct. So omega is angular velocity. So the duration of Earth to rotate about its own axis, let us suppose this is a Earth which rotate about its own axis, so it will rotate in a day how much angle? That is 2 pi radians, correct. And in what time? That is 24 hours. It will cover a distance of 2 pi in 24 hours multiplied with 3600, so it will be in seconds. So what we can say is omega is our 2 pi upon 24 into 3600 radian per second, correct. Now, putting the value of omega over here, what we get is our h comes out to be 2 pi divided by 24 into 3600 whole square into r. R is the radius of the earth, which is 6400 kilometers whole square divided by 2 into acceleration due to gravity is 9.8 meter per second. Correct. Now, the radius is in kilometer. We convert it into meter, so multiply with the factor 10 raised power 6. Correct. So, the height on calculating this, the height will come about approximately 11 kilometers. Okay. So, this is our required answer. So, at a height of 11 kilometer from the South Pole, the extension will be same. Okay. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.